The next data transfer instructions are data exchange instruction. The mnemonic for data exchange instruction is XCH, and in register addressing mode we can write it as A, RR, where RR is, you can use any register R0 to R7. So it will exchange data between accumulator and this register. For example, suppose I write instruction XCH A, R0. So it will exchange data between accumulator and R0. Suppose before execution of instruction in accumulator, suppose 20H is stored, and in register R0 34H is stored. Then after execution of instruction, accumulator will contain data of R0, that is 34H, and in register R0 will get 20H. So this is one example, that is in register addressing mode example of exchange instruction. We can use direct addressing mode also, that is XCH A, address of internal RAM memory. For example, I can write XCH A, 05H. So the data of memory location 05H will be stored in accumulator, and contents of accumulator will be stored at address location 05H. So we can exchange contents of accumulator and memory location whose address is given in the instruction. Third is indirect addressing mode. Here we can use XCH A, at RP. RP means we can use only register R0 or R1. So for example, first we have to store address of memory location in register R0. So suppose in R0 20H is stored. Now we can use 20H as the address of memory location and exchange contents of 20H memory and accumulator. So I'll write instruction XCH A, at R0. So at R0 means R0 is pointer to memory location with address 20H. So the contents of 20H address location will be exchanged with R0. So we can use it in indirect addressing mode also. The next instruction for exchange, that is fourth type of instruction for exchanges. The next instruction for exchange operation is XCHD, that is A, at RP. Means again we can use in indirect addressing mode. The mnemonic is XCHD. So it will exchange lower nibble of A and lower nibble of address location pointed by register RP. For example, suppose I write instruction SCHD A, at R0, and before that we have to initialize R0 with address of memory location, suppose 20H. So lower nibble of accumulator will be stored in the lower nibble of memory location pointed by R0. So R0 is pointing to memory location having address 20H. So R0 is pointing to this 20H, and in accumulator suppose 45H is stored, and at this memory location 26H is stored. So after execution of instruction, lower nibble of address location and lower nibble of accumulator will be exchanged. So in accumulator we'll get 46H, and at memory location the data will be, instead of 26, 25H. So only lower nibble will be exchanged using this exchange instruction. So accumulator is the operand. One of the operand in the instruction must be accumulator for exchange instruction.